Okay, so in this modern physics, so we have learned about radioactive decay. Radioactive decay consists of 3 types of decay, which are alpha decay, beta decay, and gamma decay. And you have also learned about half-life and how to solve problems involving half-life in our daily life. And the second part in this chapter also, you have learned about nuclear energy, 2 types of nuclear reactions, which are nuclear fission and nuclear fusion. And you have also learned about how to use the formula of E equals to mc squared in solving the problems involving the relationship between energy and also the mass defect. All right, so we will go through those, especially the ones involving calculation. Now for our alpha decay, okay, so let's recap back. Alpha decay, now the characteristics of an alpha decay is when it decays, it will release an alpha particle. An alpha particle, which is also the same as the helium nucleus. Okay, so this one is the characteristics of an alpha decay, helium-4 2. All right, helium-4 2 means that it has 2 protons. Okay, this number 2 here means the number of protons. And 4 means the nuclear number, which consists of 2 protons and also 2 neutrons. Right. So that one is for alpha decay. Next one is beta decay. Now beta decay, it will emit an electron. Okay, it will emit an electron. So as you, from this equation here, you can see that there is an electron written down there. E0 negative 1. Negative 1 means the charge. The charge of an electron is negative 1. Okay, negative 1. And 0 means the mass of an electron, which is very, very small. Doesn't mean 0 to kan? Doesn't mean it doesn't have any mass, but actually the numbers is very, 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 very small. A lot of 0 actually. Okay, so it will, the numbers is rounded off to become a 0. Right, so that one is for beta decay. Okay, which consists of an electron. Now gamma decay, it doesn't involve particle. It doesn't involve alpha particle or beta particle, but it is ray, sinaran. So means that it doesn't have any charge and it doesn't have any mass because it is only a ray. Okay, it is neutral and it doesn't have any mass because it is a ray. Okay, so that one is for gamma decay. So looking back here in the next page, okay, so let's try and do the exercises involving the calculation. So the important thing here is the numbers or the total numbers on the left-hand side of the equation must be equal to the total number on the right-hand side. Okay, so let's try and do question number 1. Question number 1, fill in the empty spaces with suitable answers. So what is the nucleon number and also the proton number? Element X, and then this one is A, and then this one is Z. Okay, so what is the proton number for radium? Ra. TH is thorium, Ra is radium. Radium kah? Okay, let's check again dia punya forgot already where I put the apa? Dia punya, where is that thing? Ayah, hilang. Okay, never mind. They're predictable. Don't know where I put it. Okay, so what is the number? $226 and 88. Okay, so how to get that number is by subtracting the numbers on the left and the numbers on the right hand side of the equation. So 90 minus 2 is supposed to be 88. And then 230 you minus by 4, it should be 226. Okay, correct. Okay, number 2, ferrum or iron decay to become cobalt and releasing a beta particle. This one is alpha, this one is alpha, this one is beta. 59 and 26. Okay, correct. 59 and this one is 26. Okay. Nama. Number 3, thorium decay to become radon and releasing a beta particle. This is a beta particle. 234 and 91. 91. Okay, correct. Number 4, barium decay to become a barium. So what is the missing? Yeah, gamma, kan? So gamma ray, so you can just write it, the symbol. Just write the symbol for gamma. Okay? Symbol for gamma. Next one. Number 5. Number 5. So what is the missing number? 0. Okay, so means that it will release beta particle, kan? Or electron. Okay, so E0 negative 1. Okay, ngam. Number 6. Polonium decay to become lead and releasing alpha particle. This one is an alpha particle. What is the missing number? 200. 208. You sure? 208? $84 is correct. Yeah, 210. Okay, 210 and 84. Okay, next number, number 7. Radium decay to become radon and releasing apa? What particle? Alpha particle, yeah. Alpha particle, so means that it is referring to helium 42. Okay, helium 42. And number 8, cobalt decay to become cobalt. What is the missing number? Releasing gamma ray. Same number, kan? Same number but more stable because it has released gamma ray. Okay. This one easy saja because only involving plus minus. Okay, you have passed that one. Now let's look at decay series. Now this decay series means that the element will undergoes a few decay for it to become stable. Now how to read dia punya nuclear number and also proton number. So for P, so let's look at P. Okay, so this graph is nuclear number versus proton number. Okay, nuclear number is A and proton number is Z. So to write that element, X is the element, unknown element. So A is the nuclear number and Z is the proton number. Now for P, how do we write dia punya apa tu? For P. P is, what is the number for P? So we start with the nuclear number and then followed by proton number. So P is 142. Dia macam yang coordinate lah. This is like coordinate 142. And the proton number is 33. Okay, yes, 142 and 33. Now, what about Q? Q is 142 and 34. Now, what type of particle or what type of decay happen here? From P to Q, what type of decay? Beta decay kan? Beta decay. Okay, so beta decay. So we can put there, this one is beta decay. Okay, so now R. We go to R. R, the nuclear number is 138 and the proton number is 32. Now from Q to R, what type of decay happens? What is the process of decay? Alpha kan? Because 142 decreases into 138, okay, decreases by 4. And then dia punya proton number decreases by 2. So for sure this one is referring to alpha. R pergi kepada S. S is 134, 30. Alpha juga, yeah. This one also alpha. S to T? Beta. Beta. T to U also beta. U to V is alpha. Alpha kan? Now, how many alpha particle and how many beta decay? Sometimes the question will ask, how many alpha decay and how many beta decays is in the series? Okay, so alpha decay ada 3 and beta decay is 1, 2, 3. 3 also, kan? Yes, 3 alpha and also 3 beta decay, correct. Okay, so when you get this type of question, make sure you know how to identify dia punya alpha decay and also beta decay. Quite simple actually. As long as you know how to identify that alpha decay is referring to the helium-42, and beta decay is referring to electron 0, -1. All right, so itu pas. Okay, sudah. Okay, next one we'll go into this thing. And we know that in terms of charge, alpha particle is considered as positive. Okay, alpha is considered as positive. So in terms of penetrating power, because the mass of an alpha particle referring to helium-42, because the mass is quite big, so in terms of penetrating power, it is very low. Okay, because the mass is big and the size is big, so in terms of the penetrating power, alpha particle is cannot penetrate through paper. It can be stopped by a piece of paper, and it can also be stopped by our skin. But in terms of ionizing power, alpha particle is very high. This is because of the number of charge for the proton here is 2, plus 2 actually, plus 2, which is quite high. So ionizing power for alpha particle is high. Now for beta particle is denoted as an electron, which is negatively charged. In terms of penetrating power, it can penetrate through paper, but it can be stopped by a few centimeters of aluminum. Okay, it can be stopped by a few centimeters of aluminum. And in terms of ionizing power, because it has a charge of -1, the ionizing power is medium. Okay, it is only medium. And gamma ray. Gamma ray, because it is not a particle, it is only a ray, so it doesn't have any charge. Doesn't have any charge, so we considered it as neutral. So because it is a ray, so the penetrating power is very high. It can penetrate through paper. It can penetrate through our skin. It can penetrate through aluminum, but it can be stopped by lead or concrete. Okay, it can be stopped by lead or concrete. But in terms of ionizing power, because it is neutral, it doesn't have any charge, then the ionizing power is very low, right? It is very low. All right, you got that? Now for the exercise here, sometimes the question will ask you to draw the deflection for each of the alpha particle, beta particle, and also for the gamma ray. So this one, we have a negative plate at the upper part and the positive plate on the lower part. So if we have the radioactive source here emitting these 3 types of particle and also ray. So for alpha particle, where will it be deflected to? The positive plate or the negative plate? For alpha particle. Going towards the negative plate. Yes, because opposite charges will attract each other. Yes, correct. So you draw that one going to here lah kan. Okay, don't forget to show dia punya apa tu. Wait Okay, so this one is alpha. Next, for beta particle. Beta particle is negatively charged because it is an electron. So it will be deflected towards the positive plate. Right? So this one is beta. And what about gamma? Gamma is a straight line. Yes, because it doesn't have any charge. Doesn't have any charge. So it will just go straight. Doesn't have any charge. Okay? Now, when you draw this kan, make sure dia punya apa tu, the deflection for the alpha particle is bigger than the deflection for the beta particle. Now, why is that? Why is the deflection for the alpha particle bigger than the deflection for the beta particle? Can anyone explain? Due to what? You don't know? Okay, you compare the mass of the alpha particle and also the mass for the beta particle. And you relate that mass to inertia. So what is the relationship? Macam kamu mau cornering itu kereta lah kan? At the corner there, you want to corner. Kancil and also a lorry. Yang mana satu akan menghasilkan cornering yang besar? The lorry or the kancil? Yeah, lorry kan? Because the lorry has a greater mass. So greater mass means a greater inertia. So like in this case, alpha particle, the same as helium punya apa tu, element, it has a bigger mass compared to the beta particle, which is an electron. So bigger mass, bigger inertia. So it will produce a bigger deflection towards the negative plate compared to the beta particle deflected towards the positive plate. Alright? So that is apalah. Kalau ada jumpa soalan macam itu, that is how you answer. Okay, alpha particle will have a bigger deflection due to its greater mass compared to beta particle. Bagi tahu begitu sajalah, and then you will get 2 marks. Alright. Okay. Number 2, arrange alpha, beta, and gamma radiation in the order of increasing penetrating power. And then suggest the material for X, Y, and Z. So how do we write dia punya order tu? The order of increasing penetrating power. Order of increasing penetrating power. Increasing penetrating power means we start from the lowest penetrating power and then to the highest penetrating power. So the lowest will be alpha, beta, and gamma. Correct. So dia punya order is alpha, beta, and then followed by gamma. Now identify what is X, what is Y, and what is Z. What is the material of X? Paper. This one is paper. And Y? Aluminium. And Z should be lead or concrete kan? Yes, thick lead or concrete. Right, correct. Okay, next. Sources of alpha particles are not suitable to be used as tracer in the medical industry. Based on your understanding of alpha's ionizing and penetrating power, explain the reason. Now, why is that? Not suitable to be used as tracer in the medical industry. Why is it not suitable? Okay, in terms of ionizing power, alpha particle is high. And then what happens if the alpha particles goes into our body? What will happen? What will happen to our cells inside the body if the alpha particle goes into our body, into our blood system and all that? What will happen? Will we die? Damage. Will we have blood clot? Stroke? All right. So usually they say that the good ions is negative ion. So alpha, because it is a positive ion, when it enters our body into our blood systems, so it will be attracted to the negative ions in our blood system. And then what will happen is blood clot will happen, and then eventually the oxygen supply will be cut off and will not reach our brain. So eventually we will die because of the exposure to this alpha radiation. Okay, so itu satu lah dia punya effect. And then another thing, alpha particle is also not suitable to be used as a tracer in the medical industry because of the penetrating power is very low. Okay, remember, penetrating power for alpha particle is very low because it can be stopped by our skin and also a piece of paper. So it won't be able to penetrate through our skin. So that's why it is not suitable to be used as a tracer. But if we are exposed to this alpha radiation, ini radiation, not as a tracer. Itulah like what I have explained just now. It will be able to make our blood become clotted, and then eventually the oxygen supply will be cut off from reaching our brain, and then we will be dead. Okay, so that's one of the answers that you can write if you see this type of questions. Okay, especially in essay lah. Okay. Okay, now moving on, half-life. Okay, half-life, like what I have explained before, for half-life, the basic thing is for you to be able to divide the numbers by 2 or you multiply it by 2. Itu saja, as simple as that. So for example, like this one, now the definition for half-life is the time taken for a sample of radioactive nuclei to decay to half of its initial number. So for example here, the initial number is 16, and then after one half-life, it will be reduced to half of its initial number. So 16 divided by 2 is 8, and then another half-life, you divide it by 2, becomes 4. Another half-life, it will be divided into 2, becomes 2, and then another half-life, it will become 1. 2 divided by 2 becomes 1. Okay, so that is the basic calculation for half-life. Now let's try and do these questions here. Okay, this one is by using percentage. This one is by using percentage. Okay, don't look at the formula first. You don't look at the formula first because sometimes the formula there too is quite confusing and you might think that it is hard, but actually it is not. Okay, so this question here, a radioactive material has a half-life of 20 days. 20 days, so this one is the half-life, 20 days. Calculate the number of days taken for the activity of a sample of radioactive material to reduce to 12.5% of its initial activity. 12.5% of its initial activity. So how do we start with this question? We start with what? If you are given the initial number in terms of percentage, then you should start with the full value of a percentage is how much? Yeah, 100% kan? And then you try and do first. How many half-life does it take from 100% for you to reach 12.5%? How many half-life is that? 3 times. Okay, let's check. 3 times. So 100%, 1 half-life. Then it would reduce to half. So it becomes 50%. Another half-life is 25%. And then another half-life is 12.5%. Okay, ngam lah. 3 times half-life. Yeah, 3 half-life. Correct. So how many number of days taken for the activity? 1 half-life is equals to 20 days. So it should be equals to 60 days. Yeah, this one is 20 days, kan? 20 days, 20 days, and 20 days. So you can say that 3 half-life, so 3 times 20 days. So it will be equals to 60 days. Okay? Dapat? Senang kan? Actually, this is quite simple. And if you look at this formula, macam dia complicated kan? No need to look at that one lah. Okay? Tidak payah. Right? So you will get the answer 60 days. Much more simpler. Okay. Sudah nampak di sana. Okay, next one. Okay, ini by using decay curve. This is by using a decay curve. And actually this is quite easier juga. Easier. How to find half-life from a curve. So we look at the initial activity from the curve dulu. The initial activity is 300. So half of 300 is 150. And then you do the interpolation to read what is the value of the half-life. So it is found that the value of the half-life, this is for curve A. This is for curve A. The value of the half-life for curve A is 12 minutes. And then for curve B, yang the pink punya apa tu, curve, you can see that here, the value of the half-life is 8 minutes. Okay, sudah dapat lah. Kan, easy saja. So make sure you know how to find the value of the half-life based on the decay curve. Bahagi dua saja, and then you identify what is the number. Simple. All right, so let's try and do this exercise questions. Question number 1. Question number 1, a sample of radioactive material has an initial activity of 200 per second. If its half-life is 20 minutes, how much is its activity after an hour? Try and do that one. What will be the answer for question number 1? So again, you identify the value of the half-life is 20 minutes. This is the value of the half-life. So after an hour, how much is its activity after an hour? Try and calculate first. What will be the answer for that one? Okay, Vijay got 25. What about the rest? Did you guys also get 25 as the answer? Yang lain dapat 25 juga kah? Crystal pun dapat, Jaden pun dapat. Okay. Check Try and check. 25 also. Okay, so we start with the initial activity, which is 200 per second. 200 per second. Okay, so we have one half-life is equals to 20 minutes. 20 minutes, and then an hour means dia adalah 60 minutes. So this one is 60 minutes. 60 you divide by 20 means 3 half-life. 3 half-life kan? 60 minutes is 1 hour. All right, so means you have to divide the activity 3 times. 3 times. So we start with 200 per second. 1 half-life. Reduce to half, so 100 per second. Another half-life. Reduce to half, 50 per second. And then another half-life. Reduce to half. So how much is this activity after an hour? So this is the answer. So your final answer you should write as the activity left after 1 hour is 25 per second. Okay, so that is the answer. 25 per second. Okay, let's try number 2. Try and do it. Question number 2. Okay. This one is referring to the sample 20 days ago. 20 days ago. Now, how to do this question? Ini backwards sudah nih calculation. Try and do the question dulu. How to get the answer? You are given the half-life is 5 days. The half-life is 5 days. What is the activity of the sample 20 days ago? Okay, VJ got 3,200. Okay, what about the rest? Jaden also got 3,200. Okay, 3,200 also, yes. Ryan also got the same. Okay, so we start with the knowledge of the half-life. We have 1 half-life is equals to 5 days. Now 20 days means that 20 you divide by 5 means 4 times half-life. 4 times half-life. Okay, 4 times half-life. So 20 days ago, what if you do the calculation like this? You start with the initial value 200 kan? So 200 power of 4. Will you get 3,200 if you do it like this? Tidak kan? So this one is wrong method. So what we do is we count it backwards. So this is the activity. Now we calculate it backwards. So instead of dividing by 2, you should multiply by 2. Paham kah? Multiply by 2. Because this is going backwards kan? Yeah. So 200 you times by 2, you will get 400 per second. Okay, another half-life. You times by 2, you will get 800 per second. Another half-life times 2, 1,600 per second. And then another half-life. You will get 3,200 per second. So 4 times half-life, you multiply by 2, then you will get 3,200 per second. Okay, this is the answer. All right, can you understand this one? Is anyone having problem for question number 2? You guys can understand? Can? Right. Now, question number 3. Question number 3, a radioactive material has a half-life of 20 days. Calculate the number of days taken for the activity of a sample of radioactive material to reduce to 25% of its initial activity. Oke, berapa? 40 days. Maksudnya dia dua kali saja bahagi kan? Okay, so we have the half-life is 20 days. Okay, 25%. So again, we start from 100%, one half-life, then it will be reduced to half, another half-life, then it will be reduced to half. So we stop at 25%. So means that there are 2 times apalah half-life. So this one is 20 days, 20 days. Okay, so the answer is 2 times half-life, 2 times 20 days equals to 40 days. Okay, now number 4. What about number 4? Activity of sample Y becomes 12.5% of its original value after a day. Calculate its half-life. After a day. So the clue here is after a day. One day has 24 hours. Jadi, okay, Vijay bilang 8 hours. Yang lain, what about the rest? Do you agree? The answer is 8 hours. Okay, Sean bilang 8 hours. Ellen bilang pun also the same. Okay, check. 100%. One half-life becomes 50%. 25. Another half-life is 12.5%. So 3 times half-life after a day means 24 hours. 24 hours, we have 24 hours is equals to 3 half-life. Okay, 1, 2, 3. So one half-life is equals to 8 hours. Yeah, 24 you divide by 3. So answer is 8 hours. All right. Okay, question number 5. Question number 5, last one. Question number 5. Element X has a half-life of 3 years. If the original mass of sample is 300 grams, calculate how much has decayed after 12 years. How much has decayed? Okay, you read the questions carefully. How much has decayed after 12 years? How much? So what will be the answer for that one? Vijay bilang 281.25 gram. Ryan bilang 225. Okay, what about the others? Which one is the correct answer? Jaden bilang 281.25. Terry also said the same. All right. Okay, check. Maybelline, Ellen, what is your answer? One half-life is equals to 3 years. Okay. So kalau 12 years means 4 times half-life. So you have to divide that value 4 times. So we start from 300 grams. One half-life is 150 grams. Another half-life, 75 grams. Another half-life, it will be 75 divided by 2. 37.5 grams. Then another half-life. 37.5 divided by 2 is 18.75 grams. Now, this is not the answer because the question asks how much has decayed. So how much has decayed? How much has decayed? So you have to subtract from the initial value. So 300 you minus with 18.75. So the answer will be 281.25 grams. Okay. Okay. 281.25 grams have decayed and the remaining 18.75 grams has not decayed. Right? Dapat? Easy kan? Boleh-boleh lah. Can ba? Can. Okay. Now this one kan?